Alright, hey y'all, it's Mr. Kyle Myers Mathematics, and let's just jump into it. We're determining the limit of the sequence, or showing that the sequence diverges. If it converges, find its limit. Okay, so if it diverges, it means there's not an answer. If it converges, that means there is an answer. Typically, we don't say that infinity is an answer, but that's kind of debated. Like if you have a one-sided limit, maybe the one-sided limit is going towards positive infinity or negative infinity. It just depends on which textbook you're referring to, actually. But I don't think we'll have that problem on here because we are going to be converging, and we'll see why in a second. So this one looks really crazy, which is why sometimes if it looks really, really crazy, I'll try to sort of think about it a little bit before I start the video. Otherwise, I kind of just do it in real time. So normally I always do these videos in real time, but this one I kind of looked at a little bit beforehand, so this one will hopefully not be too long. But one thing we can do here is, because these are both to the 1 over n power, another way to write this would be if I distribute this power into both the 2 and the n, like that. So that's 2 to the 1 over n power times n to the 1 over n power minus n to the 1 over n power. And if it doesn't have anything next to it, it's just 1. So if I factor out n to the 1 over n power, I would have left over 2 to the 1 over n power minus 1. So I'm just refactoring it. And the reason why this is helpful is because we know that any polynomial. I've never tried like higher degree polynomials, but I know that n to the 1 over n and then a constant to the 1 over n, the limit as that goes to infinity is 1. So I think we can say, I know for sure that anything that's like degree 0 or degree 1, or probably anything in between, would go to 1 as well. I don't know for higher degree polynomials necessarily, but I want to say it would also go to 1, no matter what the polynomial is. So I think we could say safely here that the limit as n goes to infinity of any polynomial to the 1 over n power would equal 1. And the reason why it does that is actually kind of nice, because it's easier to see why that works if we use something like 2, which 2 would classify as a polynomial. It would be a constant polynomial. It's easier to look at it with 2. So if I say 2 to the 1/2 power, I'm saying the square root of 2. Well, the square root of 2 is about 1.4. The cubed root of 2 is a little less than that, because you're timesing something by itself 3 times in order to get 2. Let's see what that would be. So 2 to the 1/2 is about 1.4. We said that already, but I'm just confirming it on here. I'm typing this as in a Desmos, by the way. So if you're wondering why I'm looking off to the side, I'm looking at my monitor here. 1.414, if you want to go to 3 decimal places. 2 to the 1/3 power, 1.2599, so 1.260 if you're into 3 decimal places. And as you keep going and keep going, that number gets lower and lower. 1.189, 2 to the 1/4 power. If I skip to 10, 1.07. 2 to the 1 over 100 power, 1.007. 2 to the 1 over 1,000 power, now it just barely rounds to 3 decimal places, 1.001. But if I go to 10,000, now there's so many zeros that I would just get 1 if I was rounding to 3 decimal places. So definitely approaching 1, and that's what it does with constants. That's also what it does with an n to the 1 over n power. And so I don't know exactly, this is the trick with professors and teachers, is that I don't know exactly what they're looking for all the time. If they want you to be more specific or use some sort of specific reason as to why n to the 1 over n goes to 1, just let me know in the comments. and I'll be like, oh yeah, I've heard of professors wanting the answer to look like that or to see that kind of work or whatever. But there's just so many different ways that you could show that the limit would be 1 for any polynomial to the 1 over n power that it's just not, it would be too long of a video. So anyways, we basically know that if we're taking the limit of this, it would go to 1. And if we're taking the limit of this, it would go to 1. So if we put all that math together, it's 1 times 0, which is 0. So we know the limit's going to be 0. And that's essentially how it works. You could also use a t-chart. I like using a t-chart actually. I figured on this one we would just do it this way. But you could also use a t-chart. And if the professor likes a t-chart, then you would just do it that way. If you can't use a graphing calculator, you can still use a scientific calculator and plug it in that way. You would put like 2 times 1 to the 1 over 1 power minus 1 to the 1 over power, and then plug in 2, and then plug in 3, and then so on and so on. I'd probably skip around a little bit. After 1 and 2, maybe skip to 10, and then 100, and so on. That way you can see what's happening as it gets to infinity. So the limit as n goes to infinity of a sub n is going to be 0. And that is the limit of the sequence. When they say limit of the sequence, they mean the infinite limit, the limit as it goes to infinity. And a sequence will start at 1 unless they say otherwise. So that's actually about it for the video. Hopefully that's been helpful. And check out other videos that are in the series as well. I've got all the other numbers before 47. And of course, if you're watching this video and it's a little bit older, then I'll have all the numbers after 47 as well. This is on OpenStax, the OpenStax free textbook. And hopefully it will stay that way for quite a while. And that way these videos will be really, really helpful. Yeah. And if you're not assigned questions out of the OpenStax textbook, you can still use these questions to help you. Hopefully, they're similar enough to the questions that you have that were assigned to you for homework, either from the text or from an online system, that you're able to still use this. So anyways, hopefully that's been helpful. Go check out the 5 math mistakes everyone makes and how to avoid them. It's a free PDF guide on my website, myirishmathematics.com. That link is in the description below. So go check that out, and I'll see you guys in the next video. Blessings, y'all.